Okay, we got a question about number 5 in the predicting redox reactions Google form. So the way I'm going to go about doing this is you have spontaneous reactions and you have non-spontaneous reactions. We're always going to have the oxidizing agent on the left-hand side and the reducing agent, the reducing agent version of that element or that entity on the right-hand side. So the oxidizing agent turns into the reducing agent. That's how we make a table of half reactions. Now, we can say the electrons, whoever steals the electrons or whoever ends up with the electrons ends up on top. We can say that, or we can just deal with these as spontaneous and non-spontaneous reactions. So let's try this. So strontium and cerium. Cerium gains electrons in this reaction. Cerium goes from 3 plus to 0. So it gains electrons. Okay, so because it gains electrons, it's the oxidizing agent, and this is the reducing agent. No problem. So we'll put cerium 3 plus, and it's going to turn into cerium. And on the other side, we put the reducing agent. We put strontium 2 plus. Perfect. So let's see, does this make sense? This is a spontaneous reaction, so this should be a spontaneous reaction. Good, it is. So we just made a spontaneous reaction, or we're representing this as a spontaneous reaction. Now let's go through again the next one. So nickel and hydrogen. Well, nickel and hydrogen have nothing to do with these elements over here. So I'm going to start making a new table just off to the left. Whatever, it doesn't matter. So the hydrogen ions end up with the electrons. They're gaining electrons. So this is the oxidizing agent, and that's the reducing agent. So I'll put that H plus turns into H2. It's the oxidizing agent, so it goes over on the left. The reducing agent, nickel, goes on the right. Is this a spontaneous reaction? Yeah, it is. Okay. All right. So both of these things make sense given what we've been given in the reaction. No problem. So now let's move on. Cerium 3 plus is non-spontaneous to nickel solid. So let's find nickel solid. Cerium 3 plus is non-spontaneous. That means cerium 3 plus has to be below nickel. Would you agree? And what else? What else is below cerium? Strontium is. So strontium 2 plus is below cerium. So hopefully this makes sense. Let's go back. Cerium 3 plus and nickel should make a non-spontaneous reaction. Cerium 3 plus and nickel should make a non-spontaneous reaction. And they do. Okay, no problem. So far that makes sense. Now let's go to the last reaction. I'll do that in red. Platinum and hydrogen ions. Here's hydrogen ions. Platinum makes a non-spontaneous reaction with hydrogen ions. That means platinum has to be higher. And this is platinum plus or 2 plus or 3 plus or whatever, right? So let's go back through this and let's see if all this makes sense. Strontium atoms and cerium ions. Strontium atoms and cerium ions make a spontaneous reaction. They do. Good. Nickel atoms and hydrogen ions. Nickel atoms and hydrogen ions. They make a spontaneous reaction. Good. Cerium ions and nickel atoms. Cerium ions here and nickel atoms here make a non-spontaneous reaction. That's uphill. Good. And the last one, platinum atoms. Platinum atoms, they're going to make a non-spontaneous reaction with anything else in this list, including hydrogen ions, right? Yeah, that's a non-spontaneous reaction. So this, hopefully this is a perfect table. Now we just have to arrange our oxidizing agents from strongest to weakest. Strongest oxidizing agents at the top, weakest oxidizing agents at the bottom. So what our answer should be is it should be PT whatever plus. I'm saying plus 1 just because we don't know. We don't know what platinum could have turned into. Whatever. And then H plus, and then nickel 2 plus, and then Ce 3 plus, and then Sr 2 plus. So that's our strongest oxidizing agent to weakest oxidizing agent. So that should be your answer, and in fact it's 2 plus, but you don't care because there's only one option. Hopefully that made sense.